Assalamu alaikum. My name is Haseeb and my partner's name is Asad Wasim. Actually, our project is about the encryption and decryption of the audio file, which will be in the WAV format. So for that, we have written the code here, which I will explain, and then I will explain that how is it working. I will show the demo of the code that which will be encrypting the audio file. So first, for that purpose, we needed crypto in a Python. So I used Python version of the 2.6. So for that, first I've imported the crypto.cipher from the import from the AES. Basically, cipher is actually used for the encryption and decryption purposes of in the cryptography. And random is these are the functions which are built in the Python, and we use them for a need. And here I've used these functions in the AES key and AES5 key, where these keys basically are used for the decryption and encryption of the file. Basically, this is of 32-bit. This is AES key, and the AES5 is 16-bit. So basically, these keys are used combined so that it can make the unique ID for the files to be encrypted and then decrypted later. And for that, we also used random and dot choice and string, for that it makes a completely random string or a key, and we will use it. So in the next line, there is an input file which is audio1.wav. This is actually, we have downloaded this file from the internet. You see it is in the WAV format, and it will be encrypted later by this code. And also, if actually this file is actually in the same path which is holding this particular code, that's why we haven't given any specific path. But if we want to encrypt some file which is not actually exists in the same path, so we can give the actual path there, and it will take the file from that. And now these variables are used so that I will be able to recognize that which one is the encrypted file and which one is a decrypted file. And that's why I've used these strings with them, so that to particularize them that this is encrypted and this is decrypted after the function runs. And as we have mentioned in our project, that we will use the login system so that we might make it a little bit secure. So for that, the program will be asking for the username when we will run it, and then the password. And for now on, I've only set the default username as admin and password as 1234. But if in the future it can be erased, or if there is a proper database connected to it, so that other people can also use it. So now when the user will get an access to the function, the program will ask them to encrypt the file which we have given here. So if the user actually enters E, so the function will run, and with this function, here is the function, and that is actually for encryption. So what is happening here is that it will open the file, input file, which was given here as an audio1.wav for now. And this RB means is write byte. Actually, the AES algorithm works with the bytes, so that's why we used bytes. And FD is a file descriptor which is actually used for have the access of the input output resources of the from the OS. For example, if you want to open some file, so we use file descriptors for that, and we have as FD means that it will be opened in the OS by the file descriptor. And contents is equal to fd.read means that it will be having all the content that is you can say the audio file in the bytes. And encryptor is it actually needs, as I have said earlier, that encryptor and descriptor needs a key, and this key should be same so that they can access to the particular file linked to that key. So for that, AES.new is AES, we know, is the algorithm, and new is for starting the file which is being encrypted, and this is the key. And UTF is Unicode transformation format in the 8. It can also be possible in the 16 and with different variants, but we are using the 8 here to encode it. And this mode is AES.mode CFB. CFB actually means that cipher feedback node. Actually what it does is that it changes the block cipher to the stream format, so that there would be a particular stream of that key and easily accessible for that. And again, we are using the AES 5.encode UTF key, and it will be used as a combined one key. These both keys will be used as a one combined key. So after this will be done, then this encrypted audio file, this is mentioned here like this, and this is actually the reason of this, the reason of using this file is that we will be the program will be writing its encrypted version in that particular file, which I was here, and WB again is, as RB is read bit and W is write bit, so that a new file will be made which will be named as encrypted, and we will use it. Again, fd.write is for encrypting the video and writing audio, and encrypted audio is actually this that we have made, it is actually encrypting the content, and it is saving in the encrypted audio, and then we are using that content to store in the audio file. And again, for that, for the you can say ACI, I have printed the print file has been encrypted, so that user know that the file has been encrypted after this particular chunk of code runs. And for up now the user will need to decrypt the file so that they can listen to that. So for that, the program will ask itself that press type D to decrypt the file, so that user can have the decrypted version of that file. And now in decryption part, again the same key is being used, which is stored but earlier in the code, and these both keys should be same, so that they know that the program know that what is being actually demanded to be encrypted or decrypted. So decrypted audio, it will decrypt the file and it will open the contents of it, and it will again write that particular content which we use here in the decrypted audio, which have been given here as a decrypted audio file, and the file will be stored in the same folder, so that we can run the decrypted file. Now for playing that particular audio, we have also used Pi audio here. Pi audio is actually basically used for playing the audio files in using the Python. So for that, here files is equals to encrypted audio 1.0. This is actually the one which will we get after running this program, and we will get this file and it will be run by this program. Actually, how does it work is there are two things in it. There is a chunk and there is an audio. Audio is actually Pi audio is actually what is doing is that it is starting a stream, so that you can say it is a playing button, that it continues to play the sound. And chunk is 1024, it means that that particular chunk of data will be stored and used in the Pi audio. So for that purpose, we are using this line, so that it will open files again as read byte, because it also works as a byte, and it will read the files. And stream is here for starting the stream of the sound, and the code will be starting running or playing the sound. Actually, this loop is here is actually for you can say detecting the end of the file, that if as you can say we have used the chunk here, this is given here, and as if we will use it, what it will do is it will run until that chunk meets, and if the chunk meets, it will automatically stream. You can see here stream.stop stream. It will stop the stream. You can say it is a pause button, and then stream.close, it will close the stream, and audio to terminate is audio is here, and the Pi audio will be closed.